In this video, we will solve systems of equations using elimination, where I have to multiply an equation by a scalar. For this first example, I want to compare the following lines. 3x minus 4y equals 9, 9x minus 12y equals 27. Notice that those lines are exactly the same line, but they certainly don't look the same. I have 3x and a 9x, I have a 4y and a 12y, a 9 and a 27. Well, these lines represent the same line, which means the two equations must be equivalent in some way. So consider, we multiplied the first equation by 3 to get the second. So what would the first equation look like if we were to have multiplied it by a -2? This is the part I want you to answer on your own. Now, how is this useful for elimination? Well, for elimination, we have to have common coefficients. So consider the system x plus 3y equals 6, or 2x minus 7y equals -1. The 1 and the 2, or the 3 and the 7, don't match. We don't have common coefficients. So what do? We can actually use multiplication to force common coefficients. It won't change the equation, just like we saw in the graph. The equations will be equivalent, but it'll change how it looks so that we can have those common coefficients. So we have to ask ourselves, which set of coefficients are going to be easier to match? Is it going to be easier to make a 1 match a 2 or a 3 match a 7 by multiplication? Well, it's going to be pretty easy to turn a 1 into a 2 by multiplying by 2. Be a lot harder to find something that we could turn a 3 into a 7 with. So we have chosen which variable we're going to eliminate based on which coefficient set we can force to match. So let's take a look at this system and solve it. We identified that we want to multiply this first equation by 2. So if we multiply that first equation by 2, we have to rewrite the system. It's going to change how it looks. 2x plus 6y is going to be equal to 12. I multiplied that entire equation by that 2. Now that we've done that, we notice we have those common coefficients. And now we can do elimination. So we have our common coefficients. Do we add or subtract? Well, in order to eliminate, 2x minus 2x is how we get that x to go to 0. So from here, we'll be left with 6 minus a -7, which is 13y. 12 minus a -1 is a positive 13. From there, we divide by 13, so y is 1. Now we have to figure out what x is. So we use that 1 and plug it back in. Notice that I plugged it back into the original equation. But remember, it doesn't matter. This really is the same equation. I could have plugged it in here too. So x plus 3 is equal to 6, subtract 3, and x is equal to 3. So our solution is 3, 1. So a whole lot of this is still the same elimination. We're only adding the part where we have to force our common coefficients, where we have to make them match first. All right, the next problem is on your own. Ask yourself that question. Is it going to be easier to make a 2 and a 9 match or a 3 and a 1 match? So in this problem, is it easier to turn a 3 into a 5 or a 1 into a 4? So here we see, well, maybe a 3 and a 5, there's not really a thing I can multiply a 3 by to make 5. But there is something I can multiply a 1 by to get 4. So I can multiply the first equation by 4. And then I can end up with this system. 4 times 3x will be 12x. 4 times a negative 1y is negative 4y. 4 times 14 is 56. From here, we notice our common coefficients, so we can add or subtract our equations. So is negative 4 plus 4 going to eliminate, or negative 4 minus 4? And we know it's going to be addition here. So we add the two equations together. We get 17x equals 68. Divide by that 17, so we know x is equal to 4. So then we substitute that 4. 5 times 4 plus 4y equals 12. Notice I plugged this into that second equation. So 20 plus 4y equals 12. Subtract 20 from both sides to get 4y equals negative 8. Divide by 4 to get y equals negative 2. So our solution is 4, negative 2. All right, once again, ask yourself that question. Is it easier to turn a 3 into a 2, or vice versa, or a 3 into a 1, or a 1 into a 3? So look for the easiest and most efficient way to make that elimination happen. Okay, this is another on your own problem here. Is it easier to turn a 3 into a 7 or a 4 into an 8? All right, this next one. Can we turn a 3 into a 5? Is there something we can multiply a 3 by to get 5? Or is there something we can multiply a 3 by to get a 4? Well, not really. Not unless it's a fractions, and we definitely don't want to use those. So what do we consider? We have to consider common multiples of both 3 and 5, or 3 and 4. So we actually get to pick the set of variables here that we want to eliminate. Let's just say we want to eliminate the x's. I want to make a 3 and a 5 match somehow. So I need a number that I could multiply the 3 by and the 5 by to make that set match. So I could turn the 3 and the 5 into a 15. So what would I have to multiply the first equation by to make 15? I'd have to multiply by 5. What would I have to multiply that second equation by to make this a 15? I'd have to multiply by 3. And so I get this system. The first equation turns into 15x plus 15y equals 45. The second equation turns into 15x plus 12y equals 30. I've now forced those x terms to have a matching coefficient. So now I'm ready to eliminate by subtraction. So when I subtract the two equations, I get 3y is equal to 15, so y equals 5. From here, I need to substitute to find the x. Notice I plugged this back into the original equation. 3x plus 3 times 5 equals 9. 3x plus 15 equals 9. Subtract 15 from both sides, and I get 3x equals negative 6. Divide by 3, and x equals negative 2. So our solution here is negative 2, 5. But I want you to consider, would you have gotten the same solution if we had matched the 3 and the 4? This is the part of this problem I want you to do on your own. I want you to try with this same system to see if you get the same answer. All right, this problem is on your own. Ask the question, how can I make a set match? How can I make a 2 and a 5 match? How can I make a 4 and a 6 match? For this set of equations, I would either need to match a 7 or a 2, or a 5 and a 7. Also, do I have to match both at the same time? No, I only have to eliminate one set of variables, so only try to make one set match. And then the last on your own problem. Make a 2 and a 3 match, or a 4, and a 6.